Otherwise, it is a unsafe unsafe state. So you need to have this to have in a safe state mode. So let's take a look in terms of example. There will be several example for you to see and to relate in terms of this step 1, step 2, step 3, and until you're going to reach for the finish on final, which is a step 4. And let's see one by one what we can have for the simplest example first. Assume for this example 1, it gives you to have 5 processes. P0, P1, P2, P3, P4. Altogether 5 processes, and you have 3 resources. Well, let me draw. And we have 3 resources with their own different instances for the resource RA, RB, and RC. RA, we have 10 instances. And RB, we have 5. And lastly, we have 7 for 3. Okay, so this is the picture that you can have in terms of the passage. And then it gives you the snapshot at T0. What is happening at... Alamak, I delete. What is happening at the T0? First of all, it gives you a situation at T0. You have P0. At P0, you didn't allocate any of resource A, but you have a resource B and 0 for C. So it's pointing up for resource B only, allocation. And how many it takes? It's only take 1. And then you can see here for P1, it have a RA with a total of 2. So how many balance is RA? How many balance for RB? How many balance for the RC? Because you can see here, there already mentions how you have in the totals. And after you already have all allocation for all the processes, what is the maximum left? Okay, let's see next one. We have for P2. P2 we have RA. RA is 3. Another one is RC, which is 2. P3. P3 got supposedly I changed all the colors just now. Okay, P3 we have 2 here, RA, and then 1 for RB and 1 for RC. And lastly, we have P4, which is only at the R2. Sorry, RC, which is 2 only. So this is all allocations that were given at T0. So how many you can see how many already allocate for the RA, how many already allocate for the RB, how many allocate for the RC. Let's say over here we can see for RA, what color? RA 2, 3 is equal to 5 already, and lastly another one is here. This is all pointing at the RA. So all together you have 7 you already occupy here at RA, and this is the instances that available. That's why it's going to see that you have availables of another 3 to be given to other processes that needed. For RB, 1, 2, only 2 here. You can see only 2 means that you have another 2, 5 minus 2, you have another 3 availables. And what else you have here? For the resource RC. For RC, you have for P2. P2 is 2 here. And then we have P3, 1. And lastly, P4, 2. So you can see here 2, 3, 4, 5. 7 minus 2, 3, 4, 5. 7 minus 5 is equal of 2. So you can see 3 available for the resource A, another 3 available for resource B, and another 2 is available for resource C. So you can see at the available one, you have 3, 3, 2. So that is in terms of allocations and also availability. So what in terms of maximum here? So how many that you can take actually for the allocation for resource A, resource B, and resources. So it gives you actually how many the maximum that can be grabbed by P0. So you can see all together 7 plus 5, you can see all over here 7 for A, B is 5, C is 3. But you're going to see later on step by step how actually you're going to see the maximum, and it's also similar to the needs. So the contents of matrix needs here is defined to be maximum minus or deduct of the allocation. So you need to see the maximum. After you have the maximum, then you're going to deduct with the allocations, and it's going to be as a needs. So let's see in terms of the step by step how you're going to calculate the need for each process. Process 0 until process 4. Okay, this is the it's already give you the allocations and the maximum. What you need to find out is the needs. So how are you going to calculate? You're going to follow the maximum minus allocations. So how many maximums that you can have? For the resource A, if a maximum is 7 is mentioned in this tables, allocation is 0. 7 minus 0, you're going to get the needs of 7. Over here, we have the maximum of resource P. 5 minus 1 for the allocation, so the needs will be 4. And then, maximum for resource C, it will be 3. And the allocation will be 0. So that's why you're going to have the needs of maximums minus allocation is also similar to the rest of P1, P2, P3, P4. So work equal to availability. So this is so just now you already look into about the availability just now, how you're going to get the availability. So your works is equal to availability. How about your matrix? So this is the availability or a work. Step 2, what you're going to do, you need to find out the needs of course, P0 first. Later on, you're going to go deeper. So first, you're going to find out the needs for P0, whether it is more, it is less or equal to work. So you need to compare with this availability or with this work for this one. For this one, which is the needs. Later on, you're going to do. But now for the step 2, we will look into step by step. So this first needs for P0, you need to compare with your works or availability. Step 2, still similar under step 2 here, which is you need to find whether your needs is less or equal to works. You're going to compare it with the previous one step. Then you can see here, okay, finish equal to false. If it is finish, if it is a false, then it's going to be finish. Just now you're going to see for this part, of course, it is a supposedly more. Okay, whether the needs is less or equal. So if let's say this part is going to be true, because it is a more here, right, for the needs. Then for next one, you're going to see 1, 2, 2, which is it will be less or equal. Less or equal from this work. After this, you're going to go to where. So after you find and meet this condition, you're going to go to the step 3, which is work equal to work plus allocation. Now we are dealing with the P1. That's why you're going to look into the allocations of P1. So let's see our work now. Work is also similar to availability. This you're going to add on with the allocation for P1. Okay, all these steps are following the previous slide here. Okay, so if you can see, if you meet this need less or equal to work, so you're going to go to where? If there is no I exist, so then you're going to go for. But then if it is true, you're going to go to the work plus allocations. So here you can see you're going to add on work and allocation. What you're going to get? You're going to get 5 plus 2, 3 plus 0, 2 plus 0. It's not going to be 3, 3, 2. Okay, I do believe that you know already how to add on the matrix. So it is like if this x, y, z, x, y, z. So x will be plus with x, y will be plus with y, z will be plus with z. So this is your answer. So you're going to see whether your works needs how about the answer, and you're going to go and look into this. It's going to be less or equal. So you will do back and check whether it's true or not. If it is true, then you need to finish that. If it's not, you're going to see, you're going to continue back. But because it is a more, right? Now we can see here, after we done for P1, we're going to need it to be more. So we're going to do for the next step, which is process 2. Similar step. Similar step. If it is more, you're going to go to the next, which is another process. If it is less, you're going to do the work plus allocation. Okay, just now you can see it is less and equal. So that's why you need to do a step 3. But if let's say it's already more, then it's okay. You go for the next process, which is P2 now. You're going to compare similar thing. Is this less or equal with the needs of P2? Now you're going to see it is a more. Similar also here, similar also here. So what you're going to do, you're going to go to the next process. Compare. Now you can see if you compare to this, of course it's going to be less or equal, isn't it? So what you need to do, you're going to do and follow the step 3. Which is you're going to do the work plus allocation because it is less than a work. Now, sorry, now the works already changed because you already update it. So this is our new works. So when you compare with this, you're going to see it is also still less than your needs. So you're going to do the work plus allocation. How many you will get? 5 plus 2, 7, 3 plus 1, 4, and 2 plus 1 is going to be equal to 3. After that, similar, you're going to repeat for another process, which now we're doing to go for a last process, which is a process 4. Check and compare with our previous new work. Compare with our new work. So this is our new work. You compare to this, whether it is less or equal. And it is true, then what you need to do, you need to do a step number 3, work plus allocation for P4. You try, you just plus in, you're going to get the result for your new work. After that, you're going to see, after you all finish doing P4, P3, P2, P1, P0, which one that last time you need to do, just now you're going to do for the P4, for the last one. So you need to check back for the others P. If P, you're going to see the needs for every P, you compare back to the previous work, the new works that you get here. So first, let's say you compare with a P2, because just now for your P3, you already done. For P2 and P2 and P0, P2 and P0, everything is true. which is more than the works, isn't it? So you compare for P2 now, you can see whether this is less or equal, because you need to check to get this. You're not going to check and get to have more. You don't want to get this. If you have this, then you need to repeat the similar process. Just now for P2 and P0. So check here. If it is a less or equal, you're going to do step number 3. So what you're going to get? You're going to get this new work. And you will do and repeat for another one. Just now I mentioned what? For P0. Okay, you can see the follow, you can see the flow of this. Just now over here for this P0, if you stack this and this is going to be needs more than work. So if there is need more than work, you just need to skip and go for another process. But you're going to see later on you need this process. You need this process to do again and compare with the work. New works, which is updated one. After you done here, which is it is more than work, so you just ignore first, you move to another one. Then you can see here similar P2, our need here is more than work for P2. So that's why you move to P3. After you done all processes, you have the latest work value. This is the latest. So just now, which one is the needs more than work? P2 and P0. So you're going to go and reverse back to check one by one. So you're going to go and reverse check P2 first. If it is less or equal, then you're going to do the step number 3. If it's still not, you're going to move to P0 first, and then later on you go back to the P2 back after you get the new value of your work. But now it's meet this condition, so you're going to do the step number 3. Work equal to work plus allocation. Work plus allocation here, then you're going to get the value of new works now. You're going to compare this with your P0. If let's say it's still more, then what you need to do, you're going to do step number 3. After you get a new work, you repeat again the step 2 process. Okay, so that is the flow. Now it's meet the condition. So work plus work allocation, and you have the final value for works, which is 10, 5, 7. So you need to know that the system is in a safe state since the sequence is P1, P3, P4, P2, P0, which is specify the safety characteristic. Why you get this? Because you can see here, you already done checking for P2, but it is the need more than work. So you cannot finish this first. You're not going to do the P0. So you check for P1. P1 you done. So it will be in this sequence. After that, you check P2 cannot meet the situation. So you go for P3 and then P4. Then you're going to go back and reverse just now I mentioned. If let's say it is not meet here, it is more, so it will be like P0, P2. So you're going to see the flow by getting the answer of your work. So what is the safe sequence process? So this is the flow you need to meet if you want to have a safe state. So if let's say you are following this step, then you're going to get the safe state. So you need to follow the sequence. So this is the how you're going to check what is the flow of safe and how you're going to get. So this algorithm you need to remember for safety algorithm. Which flow that you're going to get the safe way. If you said, okay, after P1, P2, this is the flow. After that, like P4, sorry, I don't want to follow the sequence. Let's say over here, P1, P2, P4, P3. So this is not a safety flow. If you have this thing of your process. So the safe flow is by using this algorithm. By using this algorithm, you're going to get the safe flow, which is our answer supposedly P1, P3, P4, P2, P0. Okay, next. I think this one is quite simple. You just need to remember all these steps because my B, I'm the one who really like playing around with the numbers. So when I look into these sentences, it's very hard for me to also fast understand. But when I dealing with numbering, so I can see basically what is the value and I'm putting into the equation. So by following this equation, I see what is the condition I need to do. Whether I need to go to the step 2 or I need to go to directly step 3. So when I'm going to finish. So it is going to finish is finish I equal to true for all I when the system in a safe state. Otherwise, it is a not safe state. So that is on in terms of your safety algorithm. Okay, we're going to take a 5-minute break. For those who still not understand, you can ask me the flow and you can try to take this 5 minutes to get to understand the basic things from the example 1, the basic thing in terms of the availability, the maximum and allocations, and how you're going to get the needs. Okay, so is it okay for us to take 5-minute break?
Yes.
Okay, so we stop first, then we meet again another 5 minutes. Okay, class, can we start? Shall we start now? We continue back with previous one. Just now, we look into the algorithm one, which is Safety algorithm. Let's say you can see just now, you have a process. Maybe this one we assume is to be our CPU. First of all, just now you have P0, P1, P2, P3, P4, and you check it one by one. From P0, you check, oh, it is not meet the condition, so you done for P2, P1, and it meets. So that's why P1 is in will be sent first. Let's say for your CPU, okay, this will be go first. Then you check again, P2 not meet the condition, you move, and then P3 is meet the condition, okay. After that, you check for P4, it's also okay. So you're not going to go in terms of like looping, because this one you already done checking. So you're going to go back, reverse. But later on, after this, you're going to see if, let's say, you start with P1, of course, your P0 will be here. Okay, so now let's see another example. But it will be in a new algorithm. So let's see. Resource request algorithm. This is the second algorithm that you need to know in terms of when you have you need to check whether you are in the safe state or not. So let's request vector from process. Request equal to k. This one is similar descriptions also with our safety algorithm just now. But you need to meet similar also. There is a step by step. You need to meet a if request less or equal to needs, then you need to go to the step number 2. Otherwise, rest error condition, since process has exceeded its maximum claim. For step number 2, if request less or equal to availability, then you go to the step 3. Otherwise, going to wait, since resources are not available. Similar just now, we skip right. So pretend to allocate a request for the step number 3. So you need to check this. And if safe, the resource are allocated to PI, unsafe PI must wait, and all resource allocation state is restored. So you can try to understand in terms of the sentences, but I think using the example much better. This one is similar that just now, just to see to determine the safe state, which is basically the things we done just now for the example. Okay, now let's take a look in terms of resource request algorithm. First of all, you were given with the initial request value, and also wherever it's give, it's depend also in you. Now it's give in term of the process 1. It's depend on the question. Okay, now the question is give in term of process 1 for the request value. So this question give the request value for P1. So you need to check whether it is what is the safe state flow. First, you need to check whether request less or equal to available for this condition. If it is true, then you can use the resource request algorithm. You can continue the step just now 1 to 3. But if it is false, then you're not going to continue, and it mentions that like this. Jauh pula. Okay, for this one, P0, this one is true. Where is the example of condition? Okay, if let's say you're going to see requests less or equal to availables, then you're going to have a false. Of course, you're going to check here, and P4 for the request is give you 333. If request did not meet the less or equal availability, now you can see the request is more than availability, so it's going to be false. So cannot granted since the resource are not available. So request less or equal available is false. This request has been not fulfilled, so you cannot continue. So let's see the step just now. Example for the true condition. For the true condition for our first one, P1 request given 102. What you need to do first? Check this condition. Okay, now it's true because you can see here, this is your available and this is your request value that given by your question. So you can see, okay, it's meet. Then you can proceed to the first step. You're going to do these three things. Just now we're going to see there is a equation. You need to find out availables, allocations, and needs for the new one. So let's see what we can get for this first example. Check the availabilities for new availabilities. We're going to get the new availabilities value for this condition P1 request with this value. So the equation is availability minus request. So you have this availability, you're going to deduct with the request. So you will have the new availabilities value. Second one, we look into the allocations for P1 following this equation allocations plus with this request 102, we're going to get 302 as a new value. Later on, you're going to replace with the new value. And lastly, needs equal to needs minus request. So this is your needs, you're going to minus with your request. Then you get this value. What you need to do, you're going to replace with the new value before you're going to start. You're going to start to check what is the safe mode for the flow. Okay, now we have all these new value after we follow this request P1 by the question request 102. So we have all new value. Then we start similar things for the safe algorithm, safe state algorithm. First, because we start at P1 just now, so it will be like P1, P2, P3, P4, and another one is P0. So this is the flow when we need to check. So we start with P1 just now, okay? So we check whether P1 is needs less than equals to work or not. So this is our availability, and what is our works, we check also with our needs. So this is availability. We update to our word. Check these conditions. If it's true, then you're going to go for the next step, which is step 3. You're going to update your new work. So this is our new work. Go to the next process, which is our process 3. It is now, it depend on the flow actually. Going to see, supposedly we're going to go directly to P2, P3, P4. If let's say it's give you that, okay, last time we have the flow P1, P P3, P4, and then we have P2, P0. Forgot already the flow for this sequence. P1, P3, P4, P2, P0. Okay. Okay, now we go for our P3. P3, we will have the conditions of needs minus or equal to work or not. So this is our work, new works, and this is our P3 value. Okay, for P3 value, you compare and you're going to see this is a true conditions. You're going to update your new works. So your new works will be adding, and we have this one. We follow another one, which is P4. For P4 here, what we're going to get, true conditions. We will update. And then you're going to continue after you have this flow, going to go for P0. Maybe you can also try to check P2. If you go for P2, is it a meet or not a conditions? Okay, now we go directly to see and compare with P0. P0, you can see here, it is also meet the conditions, and going to go for the next P2. It's also meet the conditions, and this is also safe mode. For the safe, it is still under a safe state. You can try to look into, if let's say you just jumping up for P1, you go to P2, P2 we go for P3, is it is going to get this safe or not? So you try and error to get the flow of your safe new sequence. Is it a new safe sequence? Then if let's say it's all correct like this, then it is meet the conditions. And also, just now at the beginning, we have the request. Is it a granted or not? So this one is fulfill everything. So it's grant the process. Let's take a look another example. We have another request value. For P4 just now, it is false. Totally, we not going to see it. And now we have P0 request value here. So what you need to do, you need to check request and availability value. If it meets the conditions, it's true, then you're going to follow just now the step by step. Before you go deeper, what you need to get, we need to get the new allocation value, the new needs value, and also the new availability value with the following equation. So these 3 new value you're going to update to your table. Once you already update, then you're going to do the similar safe states algorithm. So you check one by one. What is the new safe sequence produced? So you can try to check by yourself, and you can see here the request result unsafe state, although resources are available for the request. System not grant the request of process 0. We try to check the sequence just now, like what we have just now, the sequence like this. Try to check whether this sequence can use for the safe algorithm or not. So if it cannot, it did not meet, then it's going to stop. It's not going to, what is the new safe sequence process? No, because the request result is unsafe state just now. So try to look into work equal to availability, and then you try to compare P0. P0 now you can see this is our P0. Supposedly we're going to do this step. Step number 1. Needs P0 works. Okay, so you need to compare this. Need P0 equal to works. Our new value, where is the table? Okay, our needs here, P0 and availability. So check whether when you start this first, okay, you need to start this first because we use the process 0 request. So you start this first. You check need P0 is 723 and our new availability is 210. It is not. So of course your sequence supposedly you need to go and compare the others. Compare to others. Oh, I think it's going to start P2. It's going to be start first, and then you're going to try to check whether you can meet or not the next condition. So this is how you're going to check the availability, which is in terms of the process and also the needs you're going to compare. So now I think we already done for the previous one. We have a lot of algorithm. Try to do all the exercise, including this exercise just now when we stopped. Check, can you meet it or not? For this question, it's directly mentioned, okay, it cannot because it's not already the answer. Because at the beginnings also, when you compare, you cannot get for the P0. When you want to grant it for the first flow. So now we move to next because we try to finish our module 7. Deadlock detections. We have a few algorithms still similar, which is RAG, and another one is deadlock detection algorithm. So allow system to enter deadlock state using this detection. Of course, because you want to detect, that's why you're going to allow it. Detect algorithm, there is two types, single instances and also multiple instances. And this is the recovery stream because there is a it is going to be also later on to recover after you go deep into the deadlock state. So under single instant of each resource type, so you need to bear in your mind this one is only single. So when you have RA, RB, RC, all is can entertain one process in one time because it's only have one instances. So no need for you to like how many process that it can entertain. No, because it's going to be only one. So huge possibilities is going to be a deadlock happen. Deadlock can be detected by using your RAG. Maintain a wait for graph node are processed. So like this is going to be pi. Let's say pi is pointing out for pj if pi is waiting for pj. Last time we play around with P and R, but now this graph we indicate it and we represent it in terms of visual for us to see. If we pointing out to something, it means that we wait for this. Let's say this is me and this is you, so I'm going to wait for you. If let's say it's like this, then you wait for me. Okay, so this is in terms of representations in terms of our visualization graph. Converting a resource allocation graph to wait for graph. First, we have the first A example here, resource allocation graph, RAG. Let's say you can see here for this part we have P1, P2, P3, P4 and P5. You have the similar RAG the last time, the simple RAG, which is at this stage P1 will request R1, isn't it? P1 will request R1, its wait R1 because R1 now owned by P2. Okay, so this part, P1 requests R1, but R1 are owned by P2. Similar meaning, it means that P1 wait P2 to release R1. Okay, P1 wait P2 to release R1. What else we have here? P2 requests R3, but R3 owned by P5. So P2 need to wait for P5 to finish. So P2 wait P5. If P5 finish, then it can get the R3. So this is at this condition. I guess you already understand this example A, RAG, because this one is very easy. Now from this RAG, you need to convert to wait for graph. Just having only P. We don't have any R in our wait for graph. So like this, just now I mentioned, this P2 need to wait for P1 need to wait for P2 to finish to get this resource R1. So we can just point it directly because this one. P1 wait for P2. For this condition, P2 wait for P5. For this condition, P2 wait for P3. For this condition, P3 wait for P4. And P2 also wait for P4. And lastly, P1 wait for, P4 wait for P1. So we just change. I think you can just try to remove all these R here. Then you will get this wait for graph for this RAG. Very simple, very easy for you to convert. Okay, next, maintain a wait for graph. Periodically involve an algorithms that searches for cycles in the graph. If there is a cycle, there exists a deadlock. There is a cycle. I think there is a cycle here. And this part also got a cycle. This part is no cycle. This part is no cycle. But I have cycle here and I have a cycle here also. So if there is a cycle, then it's as a deadlock, it's easier. Just because we want to detect, right? An algorithm to detect a cycle in a graph require an order of n power of 2 operation, where n is the number of verticals of graph. So several or multiple instances. Just now is for single. Single is very easy because you know already, no need for you to think, oh, whether it can intends 2 or more process or not. So now you know it's supposedly only one. Let's move to here for if we have several or multiple instances. That's why you need to check for the R. How many instances that it have. And in terms of the symbol here is still similar like just now, previous one, and is equal to number of processes and for the resources type. You're going to see and check, going to use the availability, allocation, and request. So try to look into what is the meaning, and let's see here in terms of the detection algorithm. In terms of example, you need to follow the flow. Comparing into the equations and also the flow and the instruction given for each step. So try to look into this step. Let's see the example much better. So you're going to have 5 processes, 0, 1, 2, 3, 4. And each of these you were given with the total instances of RA is 7, RB is 2, RC is 6. And this is the time snapshot given at T0. How many allocation, the requests, and abilities that have. So you were given also the sequence P0, P2, P3, P1, P4 will result in the finish equal to true for all I. So you can try to check whether it is true or not. Okay, the step is already given here also. First of all, work equal to availables. You check similar one just now. And then going to do works is equal to available. So your availables is 0, 0, 0. Sorry, kat sini pun ada. Okay, available 0, 0, 0. And this is your works, new works. So for allocation, PI is equal to false. For all, when you try to check, so you're going to do a step number 2. Request P0 less or equal to work. Then you're going to move forward if it is true or similar. You can see here request P0. So P0 is our 0, 0, 0. It is meet this condition, go directly. So step number 3. This step is similar one, so no need for you to worry. You have the new work update, the latest one. So you're going to compare with the next one. Going to repeat to all processes. Okay, try to repeat. Now we repeat for P1. You check work and compare with this request. If it is a works equal to work plus allocation, you check first, okay, the condition of request, whether it is true or false. And then if okay, then you're going to go for the request P2, whether it is less or equal to work. And if it is okay, then you're going to go If it is meets the condition, you're going to do the step number 3. Just now, for the P0, it's done already. Then you're going to check for P1. And then followed by P2, P3, and P4. This is similar flow, and you're going to compare and follow the step. For P2 is true. P3 is true. I think it's different parts there. P2, P3, and then you try to do P4 through, and you're going to go back. Okay, this one is teranjak sikit, this naik atas sikit, it's supposedly P2, P3, P4. And you go back to the P1 because just now you go compare your P1 is more than a work for the request. So you do it again, compare with the new work. Now I meet the condition already. So it's true and it finished. Then it's going to update true all. Okay, this one is the last one for P1. Everything is true after that. So you have the new flow, of course, for the Ceph also. So P2 requests one additional instances for type C. Just now request. This one is a new things when you look into. After you check here, can I take the table? Okay. From here, you can see when you have the allocation request, and you have the availability here. You have the P2 just now 303 and the request is 000 at the initial part. Now you're going to see that when you update it, you're going to see request less than works. This one is meet conditions, but this one is after this. And when you have the new things, you update. When you have a P2 request one additional instances. So isn't it the state of system is that log conditions or not? So you need to check, can reclaim resource health by P0, but it's not sufficient resources to fulfill other processes' requests. So deadload exists when you have a consistency of process just now P1, P2, P3, and P4. Because it's going to have the extra additionals from their value. If you can see here, because just now it's true for 000. But when you have a new request, you add extra. So it is not going to meet the conditions because we already checked for this one is true all for this request value. So let's move on the still under detections algorithms, but in terms of the usage, where we're going to apply the uses. If deadlock is detected, we must abort or roll back some of the processes involved the deadlock. So we're going to see after this in terms of next slide. Next, to detect when and how often to invoke the deadlock detection algorithm, which depend on how often deadlock is likely to occur, how many processes will be needed for rolling back. So you need to, one for each disjoint cycle only, you're going to roll back the processes. If deadlock algorithm is invoked arbitrarily, there may be many cycles in the resource graph. So we will not be able to tell which and many deadlock processes cause the deadlock because it's going to also quite complicated. When we detect When we already detect there is a deadlock, we need to know how to terminate the process. Abort all the deadlock process. Abort one process until at time until the deadlock cycle is eliminated. So you need to know after you find out, okay, there is a deadlock. You need to know how, and you need to terminate it. In which order should we choose to abort? Because there are sometimes a lot of deadlock. So you need to see there is a flow for you to find which one that you need to choose to abroad first. Let's say you have P1, P2, P3. P3. So this having, let's say, a sequence, or might be we have like a cycle like this. So for which cycle that you need to abroad first to prevent the deadlock. Priority of the process. You need to check the priority of process. Which one having a much higher process priority? Whether P3 is in a higher priority or P1 is higher priority. So the higher priority you're going to abroad first. How long process has completed and how much longer the completions. So you need to also check how long P1 will be end. So if it is can end directly, then I think you're going to go for the longest one. So resources for the process has used. So which one is the processes that you have used? Processes need to complete. How many processes will be need to determine and terminates, and is process interactive or a batch? So this is all the things that you need to consider to find out which one you're going to terminate. We just look into the flow and how actually you're going to terminate the deadlock. And after you go into the deadlock, you you try to terminate it, going to stop the deadlock. After that, you're going to try to recover back from the deadlock. So recover from deadlock, first we look into the resource preventions, selecting victims to minimize a cost. Roll back, return to some safe state, restart a process for the state. And starvation, same process may always be picked as victim, including number of rollback in cost factor. So we can summarize a deadlock state occur when two or more processes are waiting. This one is easier for you. I think all of you already understand and know what is the meaning by the deadlock. For an event that can cause by only by one of the waiting processes. So there is three principal method for dealing with deadlock. First, use some protocol to prevent or avoid deadlock. Second, allow the system to enter deadlock and then you try to detect it. After you detect, of course, you need to recover. Lastly, last time, we also already bumped into this, which is just ignore. So there is a several principle under a deadlock method. So we already finished cover our module 7. Any question? Please try to do all the exercise just to understand more in terms of the each algorithm process. I guess next we're going to do our next class. We're going to do and try to look into our lab. Or might be I will ask our coordinator whether we can share with all of you in terms of the what the schemes of next lab 3, or might be in terms the project or not. Okay, so I guess if there is no more question, we can end up our class because I'm not going to go directly to module 8. There is a lot of thing before we can go for module 8, especially might be we can go for our lab first. Okay, thank you class. Stay safe, meet you again in our next class. Bye bye.